we know that high-rise building is normally considered those building that is goes beyond 30, 35 or 40, 30 meter, above 30 meter. So that means if you divide it by 30 by 3, this is 10. Okay, from another 12 to above 35, 40 or 80 story building, it can be designed. Now, what is the design technique of those buildings? Are it really as same as what we consider at the time of design a 4 or 5 story building? No, it is not. So today I will discuss and will give you obviously a overview how to design those high-rise buildings. Very good afternoon. Myself Shubhankar Rai is a practicing civil engineer and having an expertise in the field of structural design of various type of structures for the last 23 years. So today I will discuss on a very important topic and also it is very interesting, that is high-rise building design challenges. We normally, after getting passed from the engineering college, we are very much interested to design different story high-rise building. But this is basically not high-rise. This is 4, 5, 6 story, or that maybe 10 to 12 story. But obviously, this will not come under high-rise building. But today, I will inform you that how and what we consider at the time of high-rise building. Here, the most important factors are, first of all, in case of high-rise building, we find out that 4 factors are there. Number 1 is the factors influencing structural challenges. Factors influencing structural challenges. Number 2, height and load-bearing consideration. Number 3, environmental impact. And number 4, emerging trends. So first of all, we will come to the factor that is influencing structural challenges. In that cases, we found the site location. It is also very much important. Soil condition and wind loads. Now here, as the structure is finally transfer the whole load of the structure to the soil. So the soil should have sufficient strength. It should have some sufficient capacity to take the load safely. Otherwise, what will be? The structure will collapse. It may be inclined and it may be directly fall on the any side of the building. So this is the fact. Now soil, obviously, in our Kolkata soil, it is not very strong soil. In case of North Chobbish Pargona and in South Chobbish Pargona and North Chobbish Pargona, both are very soft in nature. We found that the maximum load bearing capacity may comes 7 to 9 ton per square meter, which is very less for even a 4 or 5 story building. Now, in case of high rise building, what will be? Here, we have to go for a different foundation process, different type of foundation, that is obviously deep foundation, and that may be pile foundation. But the pile foundation is also needs some expertise and experience. The design should be come from an experienced background, because the depth of the pile may be higher. We may have to reach to the very strong strata to get the more bearing capacity. Because the bearing capacity in almost all strata is very less, because the strata is very soft, is soft in nature. Now, so soil condition we already understood how it is very much important, and so how to improve the soil capacity or enhance the soil capacity to transfer the load from a high-rise building. Site location, obviously in city, the site location, you cannot have a choice. The place is yours, is there, and you have to go for the construction. So different construction methodology are there, but you have to adopt it very efficiently and obviously very judicially. Otherwise, you cannot go ahead. Now, in case of high-rise building, we often found that the lateral load is really the more important factors are here, right? The lateral loads. The lateral loads may be two types, that is wind load and that is seismic load, right? So these loads basically, if you consider a building, then you can consider is a cantilever which is fixed at the bottom and the top is free to move, right? If the lateral force come, then what will be? The structure will bend basically, try to bend and it will produce a maximum bending moment at the bottom. So the structure, the foundation should be made in such a way and with considering all those factors which may influence, we already understood the importance of wind load. Now another factors is that height and load bearing consideration. Vertical loads and lateral forces are very high because if you go higher and higher, obviously the load will be more. Load obviously will be different type of loads are there. Those are that may be dead load, that may be live load, uh, and also the different lateral forces are there like wind load and seismic load, right? Now the environmental impact, third factor, the seismic activity, it is the very important to already discuss, and weather and climate variation. The climate variation basically the sudden force due to seismic force, it is obviously suddenly come. It is not that we can assume still we do not have sufficient improvement in this field to understand or to predefine what will be the magnitude of the seismic force will come and where. It's still out of our scope, still out of our knowledge. But obviously in few years, we may be also having sufficient knowledge to predefine or understand it on previous manner, previously already, that what the force will come and how the load will come and from where the seismic load will generate. But anyhow, we have to design the structure that should be safe against a seismic force, right? Seismic force, in case of seismic force, we have to keep all a lot of things, another things also in our mind, that we need to be designed for the fractured structure, that means crack structure basically, because crack structure, that means some crack may develop, and due to development of the some cracks in the structure, that may be in shear wall, maybe in column beam. So in hence, the force produced, the force derived on the structure, that basically dissipate. It's like a pressure cooker, right? The pressure cooker, top of the top knob, just when there is a lot of heat, lot of pressures developed in the pressure cooker, the knobs goes upward and make a whistle and the steam just go out. So in this way, we can consider the whole system, the whole structure, if develop some cracks, that means it is basically the dissipation of some force developed into the structure, right? The structural crackage will be developed only to reduce the force developed in the structure, but that should not be demolished. That should not be collapsed because we do not, it should not be a threat to the life, existing life, and any life should not be should not get any damages, right? So now the third thing, that is, fourth thing is the emerging trend. We have to consider the sustainable materials, the reuse of the materials. We should not allow to unuse some materials. We have to reuse it. Only on that occasion, we really can be free from pollution, the damping of the garbages, damping of the debris, etc. Energy efficiency, that means presently we have to think obviously about sunlight, the power of sun. We have to adopt the power and finally have to convert it for our electricity purpose. Smart building technology, anyhow. Now the structural challenges in high-rise building we faces. First of all, the lateral force, I mean the wind, the resistance against wind and seismic force. Number two, the foundation engineering, that is the foundation required to support the building and weight. But what the depth of the pile to get the sufficient capacity, because if the pile capacity is not good amount, then what will be the fact? We need more and more pile. So finally, we cannot accumulate or accommodate rather within the area we have, right? So according to our requirement, we have to understand that up to which depth we have to go and to increase the strength of the pile, and in which stratum we have to leave the pile to get the maximum strength, right? Last one is a safety, stability, and functionality. Structural integrity should be there, and performance during earthquakes. In earthquakes, structure should not be collapsed. Structure should sustain. The lateral forces. Now, obviously, IS 1893 2016, there is some modification in the code, previous code has been done here. So, the seismic code became more stringent, and as a result, we found more and more forces derived at the time of seismic undulation. Now, to accommodate that, the design should be strong. In previous time, we found that if the structure is safe for 10 number of 16 to 5 bar, the same structure have to be safe presently, then we have to go for a higher section and higher steel area. So because the more and more time is going on, the engineers are very prominent. The IS code also having touch and having periphery throughout the whole system, whole development, whole research work, and they incorporate all those things in the code. And as a result, the force ultimately become more, and we have to take care about that. We already have discussed the foundation engineering. The higher the structure, the foundation should be more strong. It should be strong against the lateral forces. That means structure should not overturn, structure should not fall. So these are the things, right? Then the safety, stability, and functionality, structural integrity and performance during earthquake, right? Now, the safety, stability, and functionality, structural integrity and performance during earthquake. Solution to the structural challenges. Now, to reduce the force, if the undulation is there at the ground, then the structure will vibrate and a lot of force is basically developed. Now, there are several systems to reduce the force which is into the superstructure due to the vibration at the ground level. We can use the tune mass damper in the structure. It is basically a system, a weight that is posted at the top of the building in such a way that due to vibration, it will basically counterbalance the vibration. The structure may be designed to withstand the structural force due to earthquake. And there are different type of structural systems are there. That is moment resisting frame, they may be there. There may be some shear wall, which will basically help to increase the resistance against the shear force. Then we can go for belt truss system. For the high-rise building, belt truss system is basically very helpful. Number 4 points is tubular structure. Tubular structure, there is the outer tube and there is an inner core. This is also tube or the bundle of tubes, right? So this is the tubular structure. So in this way, we can find out, we can reduce the force and we can counterbalance the disturbing force due to earthquake. High performance material. If it is go higher and higher, then the obviously strength of the concrete should be more. Otherwise, the section will be much more, which is, and finally the structure became uneconomic because the space will not be available. Space, higher section, it will reduce the space of the usable space. So obviously we have to go higher grade, and obviously it will reduce the section and finally help to increase the area, the space area to use. New technologies for load distribution, improved structural stability for the load distribution. That means some damper may be there, some bracing may be there. Bracing will basically help to transfer the load from weaker side to stronger side in this way. Now we have made a lot of case studies, and from all those case studies throughout my whole span of 23 years, and I am honored to work with different high-level structural engineers in India and abroad. I find out that retrofitting for improved safety, that is strengthening existing structure case studies, what we can do in practical, that is we can strengthen some existing structure, because in case of existing, the structure is already exist. It has been denied previously, so a lot of precaution, lot of things which has been incorporated in the present code that has been not considered at that time, and as a result those structures are safe in this present perspective. So we have to strengthen it. There is a several system to strengthen the existing structure. We can increase the section of the column by providing higher strength steel and concrete as a cover against that, and like that. Lessons learned from renovation, improving structural performance and extending building life. Renovation, we can renovate and improving structural performance. There are several systems to increase the structural performance, like providing some bracing and providing some damper, etc. Sustainable design practice. All structures now should be sustainable, because energy, this should be energy efficiency, this should be green building, and we have to think about the reuse of the materials, which is basically debris. Right? Now, from all those things, we can conclude then safety and functionality, sustainable design, and innovation in design. Finally, we have to draw the conclusion, that is safety and functionality. Structural design ensure building safety and performance. Sustainable design, there's a green material and energy efficiency solution, efficient solution for the better future. And innovation in design, emerging technologies and material created innovative solution, right? So we can draw, there's a high-rise building. We have several conception was already there for designing of 4-5 stories buildings. So now I try to provide you some information, what the concept at the time of designing of high-rise building, what the different loads may come, and what the different system we can adopt. That is truss belt system, frames, resistance, moment resisting frame system, tube system, tubular system. So the different sets of systems are there. And to counterbalance the force, we can go for the base isolation of the foundation. Base isolation is basically a technique to reduce the effect of the seismic undulation to the superstructure. This is basically, superstructure is basically separated by the base isolation system, separated from the underground structure by the base isolation system, and hence it will reduce significantly the effect of vibration due to seismic force to the superstructure. So obviously, under this condition, the load will come less. We have to the expenditure will be less, because we don't have to design for a higher section for a higher steel, right? Thank you. So I hope this session will prove informative to all of you. It will basically give us an overall view and derive a concept within us, that how we can go for the design and what the loads what the system you can adopt at the time of designing of a high-rise structure, right? So today, this is the end of our session. On the next day, we'll come with a very, very important and beautiful topics. That is the importance of geotechnical investigation and how it can help us to reduce the cost of any of your project. So very soon, we'll bring that video to you to understand the importance and to take care of them. Thank you. Bye.